Hello everyone, welcome back. Today we are going to discuss the type of solvents. Very interesting topic because all the reactions which are taking place involve solvent. Solvent has an effect on the reaction. Is it SN1, SN2, SE1, SE2, E1, E2? Solvent has a very important role to play, and then we say this is polar solvent. And if it is polar solvent, is it protic or aprotic? We are confused in those words. But today, at the end of the lecture, you are comfortably say that we know what is polar protic solvent and what is polar aprotic solvent. And then non-polar solvents. Non-polar solvents are always aprotic. Now, let us discuss the term protic and aprotic. Protic means the solvents which give proton, which is able to give proton, H plus ion. And those solvents in which hydrogen is attached to oxygen or nitrogen, they are protic solvents. And if it is attached to other than oxygen and nitrogen, they are called aprotic solvents. I have covered almost all the solvents involved in the reactions in the chemistry. So today, after watching this video, you are able to identify any solvent involved in a reaction. So let's go to the next slide. So our topic is types of solvents. First is non-polar solvents. So non-polar solvents are those solvents which have no polarity. Even though they have sometimes polar bonds, but overall the molecule is non-polar. Means their dipole moment is zero. Like benzene, all the hydrocarbons are non-polar. Hexane, benzene, cyclohexane, they are all hydrocarbons. Now carbon tetrachloride, that is interesting because in carbon tetrachloride there are 4 CCl bonds. All the CCl bonds are polar. So this is the trick, that if all the bonds are polar and only polar bonds are present and arranged in the molecule without having any lone pair, then the molecule is, as a whole, molecule is non-polar. So polarity due to one is cancelled by the other. Okay. So in this way, carbon tetrachloride is a non-polar solvent. Same is the case with carbon disulfide. That is quite obvious. But CCl4 is something different, because in CCl4 all the CCl bonds are polar, but because of the symmetrical arrangement of the bond pairs, CCl bonds, their net polarity is zero, their net dipole moment is zero. So they are all non-polar solvents. Okay, and all the non-polar solvents are aprotic. All the non-polar solvents are aprotic. They are not able to give or accept proton. Okay, benzene, hexane, cyclohexane, carbon tetrachloride, carbon disulfide, none of them can give proton. So they are aprotic non-polar solvents. Keep in mind, all the non-polar solvents are aprotic. There is no question of protic and aprotic in case of non-polar. They are always aprotic. Now come to the next slide. Polar. So when we talk about polar solvents, these solvents are of two types: protic and aprotic. Polar protic, polar aprotic. You know, SN1 reaction, they are favored by polar protic solvents. But SN2 reactions, they are favored by polar aprotic solvents. See, polar protic, polar aprotic. Today you are able to clarify what are protic and aprotic solvents. So I have written it in the question answer format. First is water. So, in water there are two bond pairs and two lone pairs. That's why water is polar solvent. Now, is it protic or aprotic? Obviously, water can give H plus ion. That's why it is protic solvent. Second, methanol. In methanol, oxygen is attached to hydrogen. So, or we can say hydrogen is attached to oxygen. So, it is polar as well as protic solvent due to the presence of OH bond. Ethanol on the same line, it is again protic, polar protic. Methanoic acid, formic acid. Again, it can give H plus ion. It has OH, C double bond O groups. Therefore, they are also polar, formic as well as acetic acid. So both are protic. Next, ammonia. Again, in ammonia, there is one lone pair and three bond pairs. Polar, hydrogen is attached to nitrogen. Protic, acetone. It is also very common solvent used in organic chemistry, acetone. So in acetone, due to the presence of C double bond O, it is polar. But as hydrogens are attached to carbon only, hydrogen is not attached to nitrogen or oxygen. That's why it is aprotic solvent. It is polar, but it cannot give H plus ion. That's why it is polar aprotic solvent. Next, most common DMSO. It is DMSO, dimethyl sulfoxide. What is its full form? Dimethyl sulfoxide. So DMSO, it is again polar. Now tell me, it is protic or aprotic? Again, hydrogens are attached to carbon, so it cannot give H plus ion. Therefore, it is again aprotic solvent. So DMSO is also polar aprotic solvent. Next one is again dimethyl acetamide. Sorry, dimethyl formamide. DMF, full form is dimethyl formamide. So tell me, is it polar or non-polar? So obviously, due to the presence of C double bond or CN bond, it is polar. But again, hydrogen is not attached to nitrogen or oxygen. This is the trick. If hydrogen is attached to nitrogen or oxygen, that is protic. If they are attached to other than nitrogen and oxygen, hydrogen is attached to the atom other than nitrogen and oxygen, that is aprotic. It is polar but aprotic. Come to the next slide. Now it is dimethyl acetamide because CH3 C double bond O NH2 is acetamide. So two hydrogens are replaced by methyl. So it is DMA, that is dimethyl acetamide. So again, due to the presence of C double bond O and CN, it is again hydrogen is not attached to nitrogen or oxygen. So it is again aprotic. Benzene, it is not polar. Benzene, it is non-polar, not protic. It is only aprotic. Cyclohexane, pure form of cyclohexane, non-polar, not polar, not protic. It is aprotic. hexane, non-polar, not protic, it is aprotic. Next, dimethyl or diethyl, you can say. Most common is diethyl ether. So diethyl ether, CO, due to the presence of CO bond, it is polar, but quite obvious, hydrogen is not attached to oxygen or nitrogen. So it is aprotic. CCl4, you know, it is non-polar, it is not protic, it is aprotic. Chloroform, is it polar or non-polar? Keep in mind, there is one CH bond. See, trick is, what is the trick? If all the bonds are of same type, like in CCl4, all the bonds are of same type, no lone pair, and all bond pairs are of same type, that is non-polar. But if only bond pairs are there, but bond pairs are of different type, or we can say bonds are of different type, like there are 3 CCl and 1 CH, so it is polar. But again, hydrogen is not attached to nitrogen or oxygen, so it is aprotic. Dichloromethane, CaCl3 is chloroform, you know. Carbon tetrachloride, this is dichloromethane. Again, polar, because there are 2 CH bonds, 2 CCl bonds. Again, aprotic, is called acetamide or methyl cyanide. This is again polar due to the presence of CN bond. But is it protic or aprotic? Quite obvious, it is aprotic. I think you have an idea now what are polar protic and polar aprotic. Ethyl acetate, this is acetate group and this is ethyl. So in ethyl acetate, there are C double bond O, CO bonds, and therefore it is polar, but aprotic, because hydrogen is not attached to oxygen or nitrogen. There is no nitrogen, so we talk about oxygen only. Pyridine, this is pyridine. So you know, in pyridine, CN bond is there, and due to the presence of that, and at the same time nitrogen has lone pair, so it is polar, but again aprotic. THF, full form is tetrahydrofuran. This is furan. So if 4 hydrogens are added, that becomes tetrahydrofuran, and that's why it is polar due to the presence of CO bond, and oxygen has no hydrogen, or we can say hydrogen is not attached to oxygen. That's why it is not protic, it is aprotic. That's all for the day. I hope you understood. I am Dr. Suresh Thakur, your chemistry mentor. Do like the video and subscribe to my channel. Bless you all. Happy learning. Jai Hind. Jai Bharat.